Hey, everybody. So we're looking at 15.2 angle relationships and circles. Go ahead and take a minute, get this title, copy the slide, and then we'll get into it. Okay, so if you guys remember, the way this chapter or this section breaks down is angles that are created when lines are crossing through a circle. Okay, we've already seen this first type here, angles on the circle. If you guys remember, those are called inscribed angles. All right, I'm going to touch on that first, but really what this section is about are these two new types. Okay, where two lines just randomly cross in a circle, and we have angles inside, and then where two lines cross and we have angles outside the circle. Okay, but to get started, let's just recall the little rule for inscribed angles when they're on the edge of the circle. All right, what I'm going to do is I'm going to call the angle angle x. Okay, so go ahead and get this with me. Okay, the rule was that angle x equaled 1/2 the measure of its intercepted arc. Okay, for this slide, we'll just call it arc, like ARC for arc. Okay, that was the rule. The angle was half the arc, and that meant the arc was double the angle, if you guys remember. All right. The reason why I'm starting with that is because these other two formulas are very similar to this. We're using the angle, we're using the arcs. All right, but let's get into the angle inside the circle. Okay, here's its formula. The angle inside the circle is half the measure of its two intercepted arcs added together. Okay, so go ahead and take a second and get that formula. All right, the big thing I want to point out is the arcs that are being added together. It's basically the intercepted arc in front of the angle and behind the angle. And in your notes, I would recommend highlighting, like darkening those arcs. Okay, if you want to do the same thing on this one, those are what we'll be adding together. Okay, so there it is. Let's go ahead and try these out. Okay, so take a minute, go ahead and get these two circles, and we'll try these together. Okay, so you guys will see on these problems today, these angles, they're represented with a question mark. Instead of a question mark, we're just going to think of it as X whenever we see the question mark. Okay, so yeah, let's start with our formula. When we go to plug these numbers in, the very first thing we always want to plug in is the angle. Sometimes that will be our variable, and sometimes it will be a number, just depending on the problem. Okay, so on this particular problem, yeah, that's our variable, so we'll say angle X, and then that equals 1/2 the measure of the two intercepted arcs added together, just to make it completely obvious. Here's our angle. Okay, one of the intercepted arcs is this one in front. The other intercepted arc is the one behind it. Those are the arcs I'm going to be adding together. Okay, here's something to maybe just start to get used to. When you add them together, I would recommend starting with the bigger one and then adding the smaller one. Okay, that'll matter more on the other formula when we get into it. Okay, so 167 plus 55. Okay, from here we have, some math we can do inside the parentheses. If there's ever any simplifying into parentheses to be done, start with that. Okay, so that's my next step. I got angle X equals 1/2 of 167 plus 55. Let's see what we get. Okay, it looks like 222. Okay, and then yeah, last thing to do, just taking a half of that, you can probably do it in your head, and we're going to get 111 degrees. Okay, so yeah, let's try it again one more time. Okay, so there is our angle. Okay, here are my two intercepted arcs. Okay, so just like before, I'm going to start with the angle. That's my variable. I'm going to call it X. Equals 1/2 of the two arcs added together. I'm going to start with the bigger one, 135, add the smaller one. Okay, and we have some math inside, so let's see what happens. So 135 plus 169, we got 204. So I'm getting 1/2 of 204. All right, just so happens we ended up with some even numbers. That might not always happen. You might get a decimal as an answer on these, but taking half of 204, we get 102 degrees. Okay, when I get my answer, I always like to take a look at it and see if it makes sense. That being 102 degrees, like, yeah, that looks bigger than a 90-degree angle. Like that looks okay. Okay, so yeah, I'm gonna have you guys go ahead and just try a couple of these on your own, and then we'll move on to some that are a little different. Okay, so I'm going to do these pretty quick, but there's my angle. I'm going to start with it, call it x equals 1/2 of the two arcs added together, 187 plus 65. All right, let's see what happens. All right, so I'm getting 232. So 1/2 of 232. And taking half of that, just dividing it by 2, we got 116. Okay, let's take a look at this one. Same idea. There's my angle, always starting with the angle in the formula. It's my variable, equals 1/2 of the two arcs added together. Just one thing to always look for, make sure you're actually using the intercepted arcs. On these problems, that's all they're giving us, but that's not necessarily how these will always be. Okay, so I got 130 plus 62. So angle x equals 1/2 of, it looks like 192. And let's see what we got. Oops, give me a second. Looks like 96. Okay, so yeah, that's the basics of that. Here's the thing about these problems. They don't always necessarily want the measure of the angle from you. Sometimes they want the measure of an arc from you. All right, so let's take a look at a couple of those. Okay, take a second. Go ahead and just copy these. Okay, so on these problems, again, they are giving us the angle inside the circle, and they're wanting us to find one of the arcs. Okay, when we go to plug in our numbers, again, we will always start with the angle. Okay, sometimes we know it, sometimes we don't. Okay, so don't think the variable is always going to land in that spot. On this problem, that 115 is our angle in the circle. Okay, the rest of our formula is 1/2 of the two arcs added together. This looks like the bigger, so I'm going to start with that. I'm going to call this x. Okay, so x plus 55. All right, so there's a couple ways of going through this problem. Here's one way. We could distribute the 1/2. Okay, if I did that, I'd be getting a bunch of decimals, which would be okay. We have a calculator, that's fine. And if you want to do it that way, feel free. What I'm going to do is have you try something a little new, and that is getting rid of the fraction. Okay, so to get rid of a fraction, you just multiply it by the reciprocal, flipping the fraction. Okay, so I'm going to multiply a 1/2 by a 2/1. Okay, sorry if it looks kind of weird, but this is parentheses. Okay, and if I do it to one side of the equation, I have to do it to the other side. Okay, so on the left, 2/1 is the same as 2. I'm multiplying by 2. So 115 times 2, I get 230. Equals over here, these fractions, they cancel out. They turn into an invisible 1, basically, a 2/2, which disappears, and I'm left with just the x plus 55. Okay, in your notes, if you want to cross these out, you can, but you don't have to. Okay, and here we are. We just have a little one-step equation, right? We can get rid of 55 by subtracting. And 230 minus 55, we got 175. Okay, I'm going to flip it around. So x equals 175 degrees. Okay, I'm just taking a look at my circle, seeing if this answer makes sense. We're talking about the measure of an arc. All right, 175, that's really close to 180, a semicircle. Does this look like it's almost a semicircle? Like, yeah, it does. Like, this answer makes sense. Okay, always looking in the context of, does it make sense? Does it look like it's greater than 180 or less than 180? That's the way I would think about it. Okay, let's try another one. So yeah, here is my angle in the circle. Here are my two intercepted arcs. Let's start with the angle, 95. Equals 1/2 of the two arcs added together. I'm going to call this one x. I can't really tell which one is the bigger or the smaller, so I'm just going to make x the first one. Okay, but again, if I swap those, it would be fine on these problems. Okay, so again, instead of distributing the 1/2, I could distribute if I wanted to. I would get a 0.5x, and whatever half of 85 is, I get some decimals, and that would be fine. If you want to try it that way, please feel free. But I want to practice doing the eliminating the fraction. So let's multiply by the reciprocal, the 2 over 1. Okay, if we do it to one side of the equation, we have to do it to the other. Okay, so over on the left, we got 95 times 2, which is 190. On the right, fractions are gone, and we got x plus 85. Okay, last thing, getting rid of 85 by subtracting. And it looks like we're going to get 105. Okay, I'm going to flip it around. Okay, and I'm going kind of quick, so please pause the video if you need to and catch up with the equation stuff. Okay, my quick glance is, does this look like 105 degrees? Like, yeah, this looked like a bigger arc than this one, this being 85. Like, yeah, that's reasonable. That looks good. All right, so I'm gonna have you guys go ahead and try a couple on your own. Go ahead and copy these, pause the video, give them a try, and then we'll look them over. Okay, so there's my angle, and here are my two arcs. Okay, so I got 107 equals 1/2 of x plus 50. Okay, and I'm going to choose to get rid of the fraction instead of distributing by multiplying by that reciprocal. Okay, so I got 107 times 2. I got a 214 on the left, and on the right, these are gone. It just looks weird when you cross them out, but we're left with just that x plus 50. Okay, and then last thing, subtracting 50. Got 214 minus 15. It looks like a 164. There's my answer. Okay, quick look at this. That looks like it's almost 180 degrees. It does look smaller, and this is a reasonable answer. Okay, let's try this one out. So my angle, 108, equals half the measure of the two arcs added together. All right, I'm putting the variable first in these. For some reason, all of the bigger of the arcs look like our variable. But again, you could swap these and it would be completely fine. Okay, just for the sake of it, on this problem, let's distribute and see if we get the same answer. Okay, so I'm just doing this because it's another way of getting the right answer. Okay, so I got a 108 equals half of x. I would write that as a 0.5x. Okay, half of 100 would be 50. Okay, you can see it's kind of making it a little bit more complicated, but that's okay. I just want to show you that it still works. All right, I got a two-step equation. I need to get rid of 50 first by subtracting. So 108 minus 50, we got 58 equals 0.5x. Okay, and then from here, we can get rid of the 0.5 by dividing by a 0.5. And it looks like I'm getting 116. Okay, I'm guessing this is not the way you did this problem, but if you did it the other way, you still got the same answer. So just want to show that it works. Okay, so that's angles inside the circle. Let's see what happens when we end up with angles outside the circle. Okay, first thing, here's the formula. Go ahead and go back to the top of your notes and get this new formula. Okay, so if you guys notice, this is very similar to the angles inside the circle formula. We have the angle outside equals half the measure of the two arcs subtracted from one another. Here's the big thing. When we go to subtract these arcs, we want to take the bigger arc and subtract the smaller arc. All right, we always want to do that. If we flip that around, we're going to get negative measures for our angles, and we don't want negative measures. Okay, so big minus small. Let's try it out. Okay, so on these problems, we are looking for the angle outside the circle. That's our variable. So let's start with it. X equals 1/2. Okay, when we subtract our two arcs, again, we want to take the bigger one and subtract the smaller one. Okay, once you get this set up, it's pretty simple math. Start with that subtraction on the inside, right? We can do some simplifying. Don't forget that when it's there, do the simplifying. Okay, I'm getting 70 inside of there. So X equals 1/2 of 70. And then taking 1/2 of that, dividing by 2, X is going to equal 35 degrees. Okay, let's try another. So we got the variable on the outside. Again, we're going to call that x. Okay, that equals 1/2 the measure of my two arcs subtracted 173 minus 53. Okay, from here, it's basically the rest of this done in the calculator, right? 173 minus 53 is going to give me a 120. Sorry, not 120. Yes, 120. Sorry. Just making sure. All right, I got 1/2 of 120, and then half of 20 is going to give us 60. Okay, so real quick, I'm going to have you guys go ahead and try these out, see what you get. All right, so again, angle outside the circle, that's the first thing that gets plugged in. Half the measure of the two arcs being subtracted, 160 minus 44. So let's see, 160 minus 44, we got 116. Half of 16, 58. Yep, over here, same idea. So plugging in, I'm going to put my work up here. Angle outside the circle equals half the measure of the two arcs subtracted. We got 110 minus 50. It gives me 60 inside. So I got 1/2 60. Half of 60 gives me 30. Okay, it's a little bit harder to check your answers, but a 30-degree angle is a pretty small angle. That looks about right. 50 degrees is a bit bigger than it, so you can kind of gauge it by the way it looks. Okay, but just like the other problems, sometimes the variable, the thing we're looking for, is not necessarily the angle, but one of the arcs. Okay, let's try it out. Okay, so on this problem, they're giving us the angle. They're asking us for the big arc. Let's set this thing up. So always starting with the angle, right, in our formula. Okay, so 45 equals 1/2 of the two arcs subtracted. Okay, we're going to call that x. Remember, when we do this subtraction, we want the bigger arc to go first and the smaller one second. So I'm going to write this as x minus 65. Okay, just like I was doing before, I'm going to choose to, instead of distribute, I'm going to undo this 1/2 by multiplying by the reciprocal of 2/1, both sides. Okay, so that's giving me a 90 equals x minus 65. Okay, and then easy enough math. We got 90 plus 65. It's like 155. Okay, first thing I do is glance over at the arc. 155 is pretty close to 180. It's smaller than a semicircle, and that's what that looks like. Okay, let's take a look at this problem. Again, they're giving us the angle outside. We'll start with that. Equals 1/2 the measure of the two arcs subtracted. Here's the big thing. It needs to be the big arc, 150, minus the small arc, which we're going to call x. Okay, I'm going to go ahead and get rid of the fraction just like before. So multiply both sides by that, 2/1. Okay, 155 times 2, we got a 110. Equals 150 minus x. Okay, this is where we just need to be kind of careful. When we go to solve for x, we'll get rid of the 150, right? By subtracting. Okay, when I do, 110 minus 150, we're getting a negative 40. Okay, over on the right, these are gone, and I have a negative x left over. Okay, I'm a little, technically this is a -1. We can divide both sides by -1, or just remember, if we want to change the signs on one side of the equation, we can do that as long as we change all of the signs on the other side. Okay, so I'm going to flip this around and write it as x equals 40. Okay, 40-degree arc, that's a pretty small arc. I'm taking a look at this, and yeah, that looks pretty small. Okay, so I'm going to have you guys try a couple of these on your own. All right, so let's set them up, see what happens. So angle outside, we got a 36 equals 1/2 the two arcs subtracted, big arc, x. minus small arc 74. Big thing. Okay, from here, let's undo the 1/2 by multiplying by 2 over 1. Okay, so let's see, over on the left, we got a 36 times 2, which gives me a 72. Over on the right, these are gone. I got x minus 74. Okay, and then from here, we can add 74. Okay, 72 plus 74 gives me 146. I'm going to flip it around. Okay, again, I'm thinking that's a pretty big arc, almost the semicircle, and that's about what that looks like. Okay, last one here. So we got the angle outside equals half the measure of the two arcs added together. Big arc, 113 minus small arc, x. Okay, I think most of these, when you have your variable inside the parentheses, again, it's easiest just to get rid of the fraction by multiplying by that 1 over 2. Okay, so doubling 30, I got a 60. Over on the right, I got a 113 minus x. Okay, be careful with the math. First thing is getting rid of the 113. So 60 minus 113, I got negative, oops, let me change that color, negative 53 equals negative x. All right, and again, this is where I can change my right side signs to positives as long as I change the left side signs. So I'm going to flip it around, x equals positive 53. Okay, so yeah, that's angles inside the circle, angles outside the circle. Pretty simple formulas, just making sure you get all the parts plugged in correctly, and I don't think the math is too bad. All right, I'll see you guys.